Hey everybody, welcome back to Welch's Math class. Once again, we are in the business of working on a little bit more algebra today, and particularly today we're going to work on solving equations. Last time we were together, we spent a good bit of time talking about the difference between an expression and an equation. We said that if you have an expression, let's say an expression like 5x plus 2, and you set that equal to another expression, let's say like 4x minus 8. If you had one expression equal another expression, this whole thing made an equation. And our job with expressions, remember, was to simply simplify expressions. But with equations, our job is to solve equations. So we want to find out in this equation what x would be, what number would work here for x that would make this a true equation. Now today we're going to explore one of the tools that we use to do solving equations. There are a number of tools we use, but this is one, and it's called transposing. Transposing to solve equations. It's one of the ways, or one of the tools we use to help us solve an equation. And so just a real quick look right here. Essentially, let me tell you what transposing says, show you how it works on this, and then we'll write it down so you can capture it in your notes. But transposing says we can take any term in an equation. For example, in this equation we have a 5x, a positive 2 on the left side of the equal, or left side of the equation. We have a 4x and a negative 8 on the right side. Transposing says we can take any of those four terms and move them around. We can move them across the equals. And so what we want to do with transposing is we want to move terms so that we get like terms together. Okay, we want to get like terms together. In this case, we'd like to get our x's together on the same side of the equal. We'd like to get our numbers that don't have x's, as positive 2 and negative 8, together on the same side of the equal. So all we're going to do, really quite simply, is we're going to leave the 5x alone where it's at. We're going to move the 4x over across the equal with the 5x. Now, the only thing is, when we move it across the equal, we have to change it from a positive 4x to a negative 4x. Okay? So the rule with transposing is, when you move something across the equal, you have to change the sign, whatever it is. In this case, it was a positive, and when it moved across the equal, it became a negative. Now, if we're going to put x's on the left side over there, let's take these numbers that don't have x's and get them together over here on the right side. So we're going to take this positive 2 then and move it across the equal and make it a negative 2. It was a positive, now it's a negative, and put it over here with a negative 8. Okay? So that's simply what transposing is. We're just moving things around to get like terms together on the same side of the equal. Now, of course, once they're together on the same side of the equal, we can go ahead and combine the like terms. This would be a 1x, 5x minus 4x is 1x, or simply x. And then over here, negative 2 and negative 8 put together is negative 10. So x equal negative 10. So the solution to this particular equation that we came up with is negative 10. X equals negative 10. Let's give you a couple of things. That's a quick example of transposing to solve equations. Let's pretty much give you a definition of transposing now. Okay? Transposing says we can move terms from one side of the equal sign to the other side as long as we change the sign of what we moved across the equal sign. So transposing says we can move terms from one side of the equal sign across the equal sign to the other side of the equal sign as long as we change the sign of whatever it is we moved. Now, why do we transpose? Okay, that's the first part. The second part, we transpose. That is, we move things across the equal sign back and forth. We transpose to get like terms together. That's the whole reason we transpose. We don't just move stuff to move it, we move it to get like terms together on the same side of the equals. Okay, so if you need to pause the video for a second to capture this information, go ahead and do it. You definitely want to have this in your notes. So pause and capture that. And then we're going to jump into some examples of transposing. All right, hopefully you got that done and you're back with me. So let's take a look at some problems, kind of like the ones you might see in your homework or test where transposing is used to solve. All right, so a real simple problem like x plus 8 equals negative 4. We have an expression x plus 8 on the left side of the equal. On the right side, we have a simple little arithmetic expression, just a negative 4. Now what we want to do is we want to get the x by itself, so we want to get the positive 8 across the equal with the negative 4. Positive 8 is just a plain number, and it needs to go over here with this other plain number of a negative 4. The x needs to really just be by itself. So when we transpose the positive 8, we get x equals, now it'll be negative 4 minus 8, or negative 4 negative 8, and so my answer, x equals negative 12. Okay, so we just moved something across the equals, and when we moved it, we remembered to change the sign, and we had it. Then we simplified that piece. Let me give you another example. Maybe you'll work this one yourself. How about you do x plus 12 equals negative 15. X plus 12 equals negative 15. Pause the video for a second, transpose what you need to, and come up with an answer. Hey, you're back. It's good to see you. So let's take a look right here and see what you did. Hopefully what you did is you saw that this plus 12 and this negative 15 needed to be together. Okay, to get those together, we will transpose the positive 12 away from the x, and we'll get negative 15 and now a negative 12. And when we put those together, we should get a negative 27. So the solution to this equation is x equal negative 27. In other words, if I put negative 27 in for x, negative 27 plus 12 would give me negative 15. All right? Let's take a look at a few more problems. Nothing like having some examples to help you out here. Sometimes people get a little bothered by fractions with these. So let's do x minus 3/8 equals 5/6. Really, honestly, there's nothing different about this than what we've done before, except that it does have fractions. And hopefully you remember from our previous conversations about how to deal with fractions. So what we want to do again is get the x by itself. Pretty simply, just get that x by itself. So we'll transpose the negative 3/8 across. Oop. Now when we transpose it across, it's going to become a positive 3/8. So we'll leave the 5/6 alone, and negative 3/8 become positive 3/8 on this side. Now the question is, do you remember how to add fractions? If you remember how to add fractions, you're in great shape. The transposing was really no different than what we did with whole numbers. We took a negative across the equal and made it a positive. So to do this problem now, let's set up 5/6 plus 3/8, and let's find a common denominator. Hopefully you're remembering how to find common denominators. If not, then check your information back from Math 031. But a common denominator for 6 and 8 would be 24. Okay, that's the smallest number that 6 and 8 both go into, the LCD. And 6 times 4 was 24, so 5 times 4 is 20. 8 times 3 was 24, so 3 times 3 is 9, and we're adding here, so we get 29 over 24. So x equals 29 over 24. Now, if for some reason you decided you wanted to make that into a mixed number, because right now it's an improper fraction, if you wanted to make it into a mixed number, you would see that 24 goes into 29 one time, and that's 24, 5 left over. Okay, so your answer, if it's just a simplified fraction, even though it's improper, 29 over 24, fine answer. If they ask for a mixed number, then 1 and 5/24 is a really good answer. So just remembering how you work with fractions, you can transpose with just about anything. Now let's carry this transposing up a notch. Let's crank it up a notch and do a little more transposing. Let's take an equation like 4x minus 5 equals 3x minus 2. Now you notice at this stage we have some x's on either side of the equal. We have some plain numbers on either side of the equal. Guys, what we're going to do is we're going to use transposing to get these x's together on one side and to get these numbers together on the other side. Alright, so what I want to do quite simply is I want to leave the 4x alone right where it's at. And I think I want to transpose the 3x over here with it. The 3x is a positive right here. When it comes across, it becomes a negative 3x. Now, this negative has nothing to do with that negative. Okay, don't be confused by that at all, please. In fact, we could easily just make, well, we won't. But at 3x right there, it was a positive. When it came across the equal, it turned into a negative 3x. Now, if we're getting x's on the left side, let's get these numbers that don't have x's on the right side. So let's take the negative 5 and pull it across and make it a positive 5. And that's still just a negative 2 or minus 2. Now, we do our work. 4x minus 3x is x, and of course 5 minus 2 is 3. So the solution to this equation we found by shifting things around, by transposing, is x equals 3. Okay? So that's another example of transposing where we had to transpose a couple of things to get to our answer. Real simple way of dealing with, or a real simple tool that helps us to solve equations. Let's do a couple more. I think this time I want to do one that's a little more complex. We're going to do 5 times 2x minus 1, and we'll say that equals 3 times 3x minus 4. Okay? So this time we've got a little more complex equation here. In fact, what we see is parentheses here, parentheses here. What we really need to do with this equation is we need to simplify the expressions on each side of the equal separately before we try to do any transposing. We always want to simplify each side of the equal sign, each side of the equation, simplify each side before we start transposing. We'll get into that in more detail later. But we want to start this one by simplifying this expression. 5 times 2x, as we distribute, is 10x, and 5 times negative 1 is, that's right, negative 5. Okay? And then over here on this other side, of course, 3 times 3x is 9x, and 3 times negative 4 would be negative 12. Now, again, we don't want to start this by transposing. We always start by seeing what we could simplify, which you learned back in 9.5 in that last lesson we did in 9.5 about simplifying. So we simplified first, and now we've simplified both sides of the equal. Now let's go ahead and see that we've got some x's on both sides. We've got some numbers on both sides. Let's do some transposing. Let's do some transposing to get those x's together. I think I'll leave the 10x right where it's at. I'll move the 9x across and make it a minus 9x. It was positive over here. Now I've got my equal. I think I'll take the negative 5 across and make it a positive 5. And of course, the negative 12 is still a negative 12. All right, that hasn't changed anything. Now I'm going to simplify this side. Just get 10x minus 9x is x. And over here, a 5 and a negative 12 is a negative 7. So x equal negative 7 is my solution. And we did 2 steps here. We did some simplifying, and then we did some transposing before we came to an answer. Let's take one more example where we do some simplifying and transposing together and show you once again how this works. So this time on the left side of my equation, let's just do a 5 and a negative 9, or a 5 minus 9. On the right side, let's go over here and put a negative x and a positive 2 and a negative 4. All right, let's don't transpose anything yet. We see some things on the left side in this expression. Remember, this is an expression equals another expression. But we see some things in this expression on the left side that we can simplify. We can work 5 and negative 9, or 5 minus 9. Of course, that gets us negative 4. That's right. Good. Negative 4. And over here, we can take these like terms as positive 2 and this negative 4. We can put these two numbers together. Oh, lost my light. Let's fix that. Here we are back again. I got to do something about those lights. That happens just all the time. I guess it'll be all right. We can see again. So here we go. All right. So we're gonna combine here the positive 2 and the negative 4. We still got a negative x. So the negative x right here is going to equal, the negative x is going to equal, actually, I'm sorry, I shouldn't have said equal. It's going to be a negative x, and then when we put these two things together, all right, the positive 2, negative 4, we're going to have a minus or a negative 2. Okay, so hopefully you picked up on what we've done so far. We simplified both sides of the equal. Now we want to get the x really by itself. We want to get the like terms together. Now, I want to suggest something to you here that's a little different, and I want to make sure that you're kind of with me on this. To get the answer here, I really do not want the negative on the x. Okay, I don't want I just want x without the negative. So what I'm going to suggest to you guys is we're going to put our equal sign down, and what if we took the negative x and just transposed it across the equal? If we took that negative x and put it across that equal, it would be a positive x, wouldn't it? And that's really what we're looking for, is a positive x, not another negative x. Okay, so let's transpose that across to get the negative off of it and make it positive. Now, let's take the negative 4 and put it over here on this other side. It'll become a positive 4. It's now a positive 4 over here, and the negative 2 stayed a negative 2. Notice what I moved again. I moved the negative x across, became a positive x. The negative 4 across became a positive 4. I left the negative 2 alone. And so now I do my final simplify, and I get x equals 2. So the solution to this equation then, the thing that makes it work would be x equal 2. So if we put a 2 right there for the x, we'd have our answer. So remember, transposing says we can move one term, we can move any term we want to, really, across the equal as long as we change the sign. We do the transposing to get like terms together, okay, to make sure that they're on the same side together. We also make sure that we don't do any transposing until we've simplified both sides of the equal. So I simplified here, I simplified here, I transposed here and transposed here, and finished out. So that is, I believe, section 9.6. That's the gist of transposing, a wonderful tool that will help you quite a bit in solving equations. That takes care of me for now. I'll see you next time, and we'll talk about another tool we can use for solving equations called the multiplication principle. See y'all then.